Stanford University.
Okay, welcome to CS193P, lecture, I don't know what, 10? Lecture 10. Today we are going to talk about table view, and there's a bunch of classes actually that work together to make this whole table view thing work, and so we're going to go into all of those, and then I'm going to do a demo of table view and also web view, one big demo, and your homework is basically to do a big table view. So this is table view week at CS193P. So what is table view? What is this wonderful table view thing? Very, very important class. Those of you who have used numbers of apps on the iPhone will see table view all over the place, even places maybe you don't expect. And I'll show some examples in a second of things that are table views, and you're like, oh, that's a table view, huh? It is very, very customizable, ultra customizable. It has two delegates, basically. It has one delegate that's called delegate for kind of its user interface stuff, and one delegate that's called data source, and that's where its data comes from. Now, you might be familiar with this model of splitting into two delegates because some of you hopefully might have thought of doing that for the last assignment, where you had maybe your graph view had a delegate that was notifying somebody about changes in scale and origin, or getting somebody involved in that side, which is kind of the display side. And then you had another delegate maybe, or you possibly use the same delegate, but might have been better to have a separate delegate, which is the data source for your graph. Just gives the Y for X information. So that's what the table view does too. It separates those two things out into two different delegates. Now, the reality is often the same object, namely the controller, is implementing both of those delegates, but for proper API, it separates them out. The table view is very efficient for very large data sets, tens of thousands of items, and we'll talk about how it implements that efficiency. The table view, though, might seem kind of limited because it can only display one column of information at a time. All right, it's a scrollable thing, but it's not like a spreadsheet. You're not going to multiple columns and rows. It's just one column of lots and lots of rows. But it's used to display hierarchical data sets, okay, where, like, again, back to the iPod, you've got your song library in one column, but then when you click on something like your favorites, it goes to another column where it shows a bunch of albums, and you click on that, it shows another one which is a bunch of songs. So you're navigating through hierarchical data one column at a time, and that's the model that we use to display data using the table view. I'm going to talk a little bit about what the table view looks like and what we call its parts, the names we use for its parts, so that we can refer to them later. The designated initializer for a table view is init with frame : style : So when you create a table view, you have to specify its style. That's its visual style, what it looks like on screen. And there are two styles. There's the plain style and the group style. So let's talk about what those look like. Once you create a table view with a certain style, you cannot change the style. Okay? So the style is something the table view lives with its entire life, and that's why it's in the designated initializer, because you have to specify it up front. You can't change it. So here's a UI table view that's in the plain style. All right? And the plain style is focused on the rows, and the rows are the most important thing. It's just row after row, line by line, plain, very plain. That's why it's called plain style. The group style takes the rows and groups them into little sections or areas. Now, the plain style also can have sections, but those sections tend to just have little header lines in between the rows, whereas in the group mode, you can see that the sections kind of are curved around, make little bubbles. So this thing on the right is the general settings application on the iPhone, and you can see that it's divided into these little groups. But in both styles, this plain style and the group style, we call all the parts the same thing. So let's look at the plain style and what we call these parts. So here is a plain style table view. And this little part at the top is a little UI view. It's the header. And that can be any UI view you want. It could be, really big view or small view or whatever. But it does go the entire width of the table view, and you can set the height to be what you want. And similarly, it has a footer UI view at the bottom. So those are all settable by you. Then there are sections. The table view is divided into sections. Each section has a header and a footer. And those also, usually they're just strings, but they actually can be UI views as well. So every section, you got multiple sections, they can each have the UI views as headers and footers. All of this information, like what view is in the header and footer, or if it's a string, is coming from the various delegates, depending on whether it's just pure data or whether it's a graphical UI thing. And then this is the key element, is the table cell. So this is the actual row of data in here, row number 1 in section number 0 there. Is highlighted, so that's called a cell, a table cell, or table view cell. So that's the summary. So now I'm going to overlay over this the group style, so you can see all these things in the group style. Okay, so it has all the same things, right? A header, a footer, section header, section footer, and then rows in the table cells in the middle. It's just grouped differently. Okay? So how do we get data into this table? So we know what it's going to look like visually now, approximately. How do we get the data in? And the answer is we have this data source delegate that you set on the table view. And so that data source is going to be asked for the information in the table, and it's going to be asked in an efficient way. Because we wouldn't want to load up 10,000 cells worth of information at once, especially if each cell maybe had a custom view associated with it, and headers and footers with custom views. That could be very heavyweight to have 10,000 of them. So just like your graph view does, it only asks for the data as it needs it. You know how your graph view only asks for each y as it needs it, as it's going across each x. That's very efficient. It's not storing the data or duplicating it anywhere. Same thing with the table view. It's only asking for information about a row when that row comes on screen. Okay? So you could have tons and tons of information in your model, but it's only going to ask you row by row for that information. So how is the table view, though, going to manage its visual size, like the scroll indicators and things like that, if it doesn't know how many rows are? So you have to tell it how many rows and sections there are, okay, so that it can make space for it and know when to ask you as the user, thumbs up and down scrolling. And so you have to be able to provide that. You can think of it this way: the table view is a subclass of UI scroll view, and the table view it needs to know its content size. Remember, content size is the scrollable area. It kind of needs to know what that content size is. Even though it doesn't want all the data, it needs to know the size. So it's going to ask you for that. So the first thing it's going to have to do before it even starts getting data from you is ask you how many rows. And actually what it's going to ask you even before that is how many sections. So it's going to ask you how many sections there are. Some table views only have one section. In other words, there's just a big long list of rows. But it's going to ask you how many sections there are. And then for each section, it's going to ask you how many rows are in that section. And that's just, you're just returning an integer. How many sections, how many rows in that section. That question is going to be asked for each section. Okay? So you have to be able to answer that question pretty efficiently up front. Then, once it's got that information about how big this thing is, then as the user scrolls around, it's going to start asking you for the data. And we'll talk about how you provide that data, which is a pretty flexible, powerful way of doing that. But that's the way this works. Ask for how big it is, then ask for the data one by one. So let's start with the first question it's going to ask you, which is number of sections in table view. Okay, these are delegate methods. These are data source. This is the UI table view data source, but we call it a delegate. It's kind of confusing because it has another delegate called delegate, but it's still delegating things, so we call this the data source delegate. So the first question there it's going to ask you is this one: number of sections in table view. You can see the argument is the table view that's sending you the message, and it returns an NS integer. A reminder that NS integer is really just a type def for int, or depending on the platform, it could be different number of bits of int, but it's essentially an integer. And you could assign the result to an int, because you know in this case that the number of sections in the table view is not going to be 10 billion. It's going to be some number that's going to fit in an int. If you don't implement this method, it's an optional method in the data source protocol, then the answer is assumed to be one section. In other words, all your rows, one big section. Right? Which is common to just not implement this and have one big long table. So then once it knows how many sections are, for each section it's going to send you this message: table view, number of rows in section. You're going to answer how many rows are in that section. Okay, it's all very straightforward. This method, though, there's no default. It's required. You have to tell it how many rows are in each section. Okay, there's no way it can, no sensible thing for it to default to. So this is a required method in this protocol. So then once it has all the information, here's how it gets the information from you, the actual data that's going to appear in the table. It sends you this message, table view cell for row at index path, and you're going to return an instance of this thing called UI table view cell, which we're going to talk about. This is another class, and UI table view cell is essentially like a UI view. It might be a UI view that has a bunch of properties you can set on it to display your data. Okay, and the best way to do this is I'm just going to show you all these properties, or at least a handful of them, and you'll get the idea. You might ask, what's this NS index path thing? Well, NS index path is just an object that lets you specify the row and section in one argument. Okay, so it's an object that has a property called section, which is the section, and a property called row, which is the row. Okay, those methods are actually implemented as a category by UI table view, but you don't need to know any of that. Bottom line is, it's just passing you the section and row and asking you, please load this cell, load up a cell and give it to me with all the information to display in that row. So here's how this works. This is pretty obvious. I'm going to go through this quickly. It sends how many sections to the data source? The data source says 5 in this case. It sends how many rows are in section 0. The data source replies back, there's 1. And it sends that for each section. Then it sends, give me a cell for the row at this index path. So let's say the index path is 0, 0, section 0, row 0. And the data source loads up a cell with the text John Appleseed in this case and returns it back. And the table view then can display it. Okay? Straightforward. Okay, so here's some example implementations of these three methods. If the data, the model of this controller that has a table view as its view, let's say it's an NS array of strings, the very simplest possible model you can probably imagine. So it's only one big long list of strings, let's say. So there's no section information. We're not going to divide up the list of strings into sections. It's just going to be one big long thing. So I'm not even going to implement a number of sections in table view. It's just going to return 1. And then I'm going to implement number of rows in section by just returning the count of my array. How many things in my array? Simple. And then I'm going to load it up by getting a cell. The first line of code there, UI table view cell star cell equals something. We're going to talk about how you get a cell, because we want to do that efficiently. And then I'm just going to send messages to the cell like cell.textLabel. Okay, cells happen to have a property called textLabel, which is a UI label. .text equals, in this case, my array object at index path.row. My array has strings in it, and I'm just going to get the string that's at index path.row. That says what row I'm in. Remember, section is always 0 because I didn't implement the section thing, so there's only one section. And then I return the cell. So that's it. So super easy. But there's a little bit here of ... which is that UI table view cell. So let's go look at how that happens. So first of all, what is this UI table view cell thing? Before we talk about how to get one, what is it? It's a UI view subclass, as I said, for drawing a row in the table view. You set it up with the data that you want to display, and then return it. And so some of the properties it has is text label, detailed text label, image view. You can put an image in your table view cell. And note that these properties are all read-only, which kind of, a lot of times people are like, what? It's read-only? What's going on? Well, the reason they're read-only is you send this property getter, and it will make one for you at the time and return it to you. So it's lazy instantiation, right? We talk about lazy instantiation. I've talked about it all quarter long. It's a good way to do things. This is lazily instantiating. So if you never had a detailed text label, or you never had an image view on your text, it never even creates those subviews, right? So you then just call these properties, you get the text label, you start setting its text or its text color or whatever you want to set, and off you go. The designated initializer of the UI table view cell is kind of odd, okay? Init with style, so it has a style too, which is different than the table view style, and I'm going to talk about what those styles are. And then it has this weird argument reuse identifier, which is a string, and we're going to talk about what that is. But let's talk about the styles first. So here's one table style. This is UI table view style default, just white background, black letters, simple. Then here's UI table view cell style subtitle. This is a common one to use. You can see that it's the same as the one above, but there's a little dark gray subtitle. And there's two different versions of them. One of them has an image view and one doesn't. Okay, so that's the subtitle one, very commonly used. Here's one creatively called UI table view cell style value 1, which you see these in the group style table view more often than the plain style. And you can see that it's got a little value on the right, in this case push. So it's got an attribute there that's just at that value. And then there's UI table view cell style value 2, which is same thing, but now the little extra value is over on the left there. It's the word work. So you can see, you've probably seen in the UI when these various things are used, but that's what the 4 styles are. So when you create a table view cell, you have to specify the style that you want up front. So let's talk a little bit about some of the properties that are on a table view cell and where they are graphically. So I'm just going to pick a table view cell here, and you can see here's the outside property text label, which is the big label, and then detail text label is the little subtitle if it's a subtitle style. If it's a value style, it would be the little value text. Then here's the image view showing up on the left there. And there's also this little thing called the accessory type, which is of type UI table view accessory type. And it can have various values, which I'll talk about in a second. So here I've written a cell for a row at index path that loads up all 4 of these things. So you can see it just does cell.textLabel.text equals something, cell.detail text label.text equals something, and cell.accessory type equals figure out what kind of accessory type that we want. So let's find out what kind of accessory types there are. That accessory type also can be delegated. So you don't have to set it as a property on the cell. It's actually possible to delegate it through the table views delegate. It'll ask you what's the accessory type for this index path, basically the section and row. So that's nice, because if you have a mixed table view, it's nice to be able to delegate it. So what do these things look like? There's UI table view cell accessory disclosure indicator. That's the little kind of caret, the little greater than sign. Then there's the check mark. The check mark generally is considered you mostly would use it for radio mode. In other words, you would only have one item in your table view that would be checked at a time. Although you could reasonably think to use check mark as something where you're selecting a bunch of them and saying go do something. Not terrible. If you're doing the radio style where only one thing has check mark, you have to implement that yourself. In other words, you have to figure out what's my currently check marked one and make sure you uncheck the last one, said its disclosure, its accessory thing to be none, and then go back. And then there's kind of a really funky accessory type here, which is called the disclosure button, which is different than the disclosure indicator. The difference about a disclosure button is when you click on that little blue thing, it's actually going to send a message to your delegate. Okay? Whereas the one that's just a little greater than sign, it's just there, it's visual eye candy. It's just telling you that clicking here will push some other controller on, basically, and show you more information. But the blue one, you click it and it'll actually send a message to your delegate. Here's the delegate method it sends. And so you might say, when is that? That's kind of weird, because if I click on the cell, it's probably going to push something, but if I click on the blue thing, it does something else. Well, let me show you some examples later. I'll show you some examples later of some table views and where they use that. Probably the best example is the voicemail on your phone. If you think about that, it has a little blue thing there. But before we get to that, I want to get to this reuse identifier. The reason we have the reuse identifier in table views designated initializer is for performance, because we don't want to create 10,000 UI table view cells. They're UI views, which are not super lightweight objects. They're not heavyweight, but they're not super lightweight. We only really want to create about 7 or 8 UI table view cells at a time. That is the 7 or 8 that are on screen. And then we just kind of want to recycle them as they go off screen and come back on. You see what I'm saying about that? So we reuse them. And so how do we reuse them? So here is cell for row at index path again, same thing we had before with the NS array of NS strings. And now I'm going to expand that ... Okay, so keep your eyes on the ... So I'm going to take it away. Now, what I could just say is UI table view cell alloc init with style. By the way, I have to say UI TBC because I need this to fit on a slide, but that's UI table view cell. So I could just say alloc init. Now if I did it this way, I'd get 10,000 of them, okay? And that's not what I want. So how can I fix this? All right, well, let's move that out of the way, and instead, let's call this magic method in the table view. Table view is our sender because it's the table view data source delegate method. It's called DQ reusable cell with identifier type string. And so you give it a string. And what that says is, go look on my pile of table view cells that I want to reuse and grab me one. Okay? And the pile is the my TV pile. So that can be any string. You make up that string. It just names the pile of reusable table view cells. Okay? And then we say if not cell. In other words, if I couldn't get a reusable one off the pile, then I am going to init with style. And when I init with style, I'm going to specify the reuse identifier my table view. Okay? So that when it goes away, when it gets released, it'll go onto that pile. So this is how we make this work. So every time the cell goes off screen, it gets released, goes into a pile of this name, my TV, and then every time we're asked to load up a new cell, first we look in the pile to DQ it, and if we don't find it, then we create one. So you can see the first 7 or 8 times that we have to draw a cell, there's not going to be anything on the reuse pile. So we're going to be creating them with init with style : reuse identifier. But when we get to like the 9th one, because we scroll down a little bit, now one will have scrolled off the top, got thrown on the reuse pile, the queue, and we'll pull it off and put it on the bottom. So basically, if we're scrolling down, they're coming off the top, and we're putting them back on the bottom with the new cell values. Because in either case, whether we get it off the DQ or we create it, we still do cell.textLabel.text equals my text. Okay? So if we're reusing it, we're resetting the text. Is that cool? See how that works? So that's it. It's as simple as that. It's really not that complicated, but when people see that code for the first time, they're like, what's all this DQ business? It's just as simple as that. We're just reusing them, queuing them up, pulling them up, reusing them. Okay, so what else can you do to display a row besides text and image? Right? We've seen the text label, the detailed text label, image view. What else can we do? Well, it turns out you can do pretty much anything you want. First of all, the accessory area, where the little disclosure indicator is and the check mark, that can actually be a view. Okay, so you can have your own accessory view. That's, again, implemented by setting this accessory view property on the UI table view cell. You can also display a custom view in the table view cell. In other words, the entire contents of the table view cell, you can draw it yourself with a custom view. You could put a graph view in there if you wanted. And in fact, I did a demo last quarter where I actually created a table view cell that had graph views for every line in the table. Like, you know, it was showing different equations, and it would show the graph. Then you could click on an equation, it would show it to you. And you do that by getting this property content view, which if you ask for it, it'll create it, and then you add your subviews to it. So you don't set your custom view as a property, you get a property, and then you add your custom views to that thing. And you want to make sure you match your custom views frame to the content view's bounds so that it's filling the entire space, if that's what you want. Usually it is what you want. And also make sure your stretchiness is right, and so that if, you know, the height of rows changes, that your custom view will adjust to that stretchiness. And you can also subclass UI table view cell. It's a UI view, and there's actually support in Interface Builder even for doing this. So it's not uncommon. Table view cells can be pretty expanded to be pretty complicated beasts. And I'm not going to cover all the stuff you can do, but I just want you to know it's out there that you can really make very sophisticated and complicated table view cells. All right, so what else can this data source control besides what we've talked about, sections, rows, loading up the cell? It controls the content, the data, in the headers and footers. It doesn't control the view of them, right, how they're displayed. That's the delegate. This is the data source only, but it can provide a string that is the content of headers and footers. It also can control the editability of the table. So the table views have mechanism in there for being edited. And I'm going to try to be clear about the words I use. Edit in table view means to delete or insert. Delete a row or insert a row, we call that editing. Okay? There's another thing you can do with table view, which is reordering the cells, putting them in a different order. That's not editing, that's a different thing. Okay? That's called reordering, and that one's a little more difficult to implement. But in both cases, what you're required to do is essentially keep your model in sync with what's going on in the user interface. So we'll talk about those briefly. So how do we control the display of headers and footers? It has this two methods, table view title for header in section, and footer, a title for footer in section, okay? And so that just returns a string, and that'll be the string that appears in the header or the footer for a section. Remember, the rows are divided into sections. How about editing, insertion and deletion? How does that work? The main method you have to implement here, a very important method if you're going to do editing in your table view, is commit editing style for row at index path. All right? And what that means is the user has done something in the UI that says, I want to delete this row. Or they've done something in the UI that says, I want to insert a row here. And when they've done that and said they want to do that, this method is going to get called. You are responsible for two things in here. All right? You have to, let's say it's deletion. You have to delete the thing from your model, and you have to delete the rows from the table view. Okay? There's a method in the table view, delete rows, and you have to call that. So you have to do both things. If you only do one of those two things, your program's going to get an exception. Because the table view is pretty good about after it calls this, it checks to make sure that the number of sections and rows matches what you did in terms of deleting rows and sections. Okay? So you have to do both those things. And we'll do that in the demo if we have time today. I'll do some deletion. Same thing with insertion. If you insert, you've got to make sure you insert the rows in the table and in your model. You don't want to get your model out of sync with the data. And some people have said, well, why doesn't the table view just send you this message and you update your model and then it'll just redo your UI, reload the UI? Well, again, for efficiency reasons. Okay, the table view knows a lot about the row that was deleted, and it can very efficiently just close up the space and redraw, throw a new cell in, and it's done. Minimum amount of work. Whereas if you ask it to reload, it's got to go all the way back through how many sections you got, how many rows in this section, all this stuff. Very inefficient. Okay, so it does put the burden on you here when you edit, which is insertion or deletion, to do it. Now, by default, if you don't implement this method, you cannot do insertion or deletion. Period. You must implement this method. Okay, it does a response to. If you don't respond to this method, it doesn't do it. Deletion is on by default. So if you implement this method, it assumes you can delete. Okay, insertion, whether a table is doing insertion or deletion, is controlled by this editing style thing, and also by this method can edit row at index path. So you'll be asked, can this row be edited? But if you don't implement can edit row at index path, it assumes you can delete. Okay? So if you don't, it's a default of that is yes, you can edit this path. All right? Whether you're doing insert or delete is controlled by the editing style in the table view cell, which is actually delegated. So there's another delegate method, which is editing style at index path that says which one you're doing. Most often you're doing delete. When you're doing insert in a table, usually you're going to click insert and it's going to bring you to another view to let you give some information, and then it's going to go back. Like if you added a new song to your list of songs in your iPod, it's not going to put one in the table view. It's going to ask you what's the name of this song or something. It's going to need more information. So deleting is much more common editing going on. So there's the deletion. How does the user actually do the deletion? You may not know this. And it's funny, people say to me in this class, one of the most interesting things I learned was this thing about swiping to delete. If you have a table view on your iPhone and it supports deletion, in other words, it implements commit editing style, you can swipe with your finger and it'll put a delete button. Okay, so if you haven't never seen that, give it a try on your iPhone. You just swipe, whoop, it'll put a delete button. If you hit delete, it'll call commit editing style. But kind of a more friendly way to do it is to put an edit button, usually in the upper right-hand corner in your navigation controller's bar, that says edit. And that's so common, in fact, that there's a method in UI View Controller that says, give me one of those editing buttons because I want to put it on my bar. So you don't even have to create it or anything, it just gives it to you. And when you click the edit button, I'm sure you've seen that on the iPhone, then it puts a little red thing along the left-hand side that you click and toggles whether it's in delete mode or not. It's kind of like when you click it, it's like swiping. And we'll see that hopefully in the demo. Okay, reordering. I'm going to go through this quickly. I'm not really going to tell you how to do this because it's a little bit complicated. It's sometimes confusing because it's a little different than editing. These methods are all a little different. Like move row at index path. In the edit case, if you got that commit editing and you decided, oh, I don't really want to edit this, I don't want to delete, you could just not do it. But here, if you move, you must do it. So if you allow the user to move and reorder things, when it gets moved, you got to do it. You have to move it in your model and in your thing. You really can't say, oh, no, I really don't want to do that. You have to just, that's a little different. Also, the default for this can move row at index path is the opposite for the can edit. If you don't implement this can move row, it won't be able to move. So you have to implement this one. So you see how it mirrors the edit, but the defaults are kind of backwards. It's very unusual to allow reordering in a table view. It does happen, but it's much more common to do deletion and insertion. And then if you want a cell to be movable, it has to have a little thing to grab onto. There's a little control that'll appear in the user interface, a reordering control that the user touches on and then moves it around. So your cell has to have this property shows reordering control set to yes. Okay? But even if you do that, that reordering control is not going to actually be shown until you go into editing mode, which you do with that little edit button that's in the upper right-hand corner. So reordering is a little heavier weight, both for the end user, there's no swiping to reorder, and also for you. You're forced to implement a little more mechanism underneath. Okay, so all of what I've talked about so far is all part of the UI table view's data source. Okay? Now we're going to talk about its other delegate, which is called its delegate, which is really kind of its user interface delegate. It controls how things are displayed in the table view. So the delegate controls how the table view is displayed, and the data source controls what is being displayed in the table view. The delegate also lets you observe what's going on in the table view. You know, this did do that, this will do that, all those kind of delegate methods you're used to, like in scroll view, same kind of thing. And it is very common for both the data source and delegate to be the same object because the controller is usually arbitrating communication to your model, and at the same time, it's also managing the activity in your view. So it would make sense for it to be both. But they're separated to make it clear in the API of a table view. These are data methods. This is UI methods. Okay, so here's some of the methods in the delegate protocol. Here's a notification that a row is about to be displayed on screen. This is kind of like view will appear in a view controller. This gets called just before this thing gets displayed. And yes, you can actually modify your cell some more here if you want. Okay, it's not totally out of bounds to do so. You could. Normally you're loading up your cell in the give me cell at for row at index path. But here you could also set some last minute things. If you wanted to. You'll know your geometry here, for example. Same thing with view will appear. You'll know how big your cell is going to be at this point. So that's a fun one. Hugely important method is the method gets called when someone clicks on a row in your table view, right? Because you're going to want to do something, push a view controller on the stack or do something. So, and in fact, that's mostly what happens in this method is people push a new view controller onto the navigation stack. Okay, it's called did select row at index path. It's very straightforward. And we'll do that today too. So here's some examples. I told you I would show you some examples of the little disclosure button. This is the voicemail and the voice memos applications. You can see that if I click on the line in the voicemail thing, then it plays my voicemail. If I click on the little blue disclosure button, it pushes on a view controller that shows me when the call was and what its duration was and who it was from. You see? So it's kind of like two different things depending on where you click, whether you click on the row or click on the disclosure button. So that's that. So I just want to show that. So what else can you control with the delegate? You can control the height of cells. Okay? Cells, by default, are going to be big enough to hold their label and their UI image view and their detail text view, but they're kind of to set size heights. But you can actually control the height with the delegate and say, well, I want this row to be this big and this other row to be this big. So you can have variable height rows in your table. One thing I will warn you about, and one of our TAs who's out working in the real world doing iPhone programming ran across this at their job. You want this method to be very efficient, because this is going to get called 10,000 times in a 10,000 row table view, right? Okay, because it needs to know the entire size. So this thing better be super efficient. You do not want to be doing, you know, bounding box on my subviews, and you know, you want to have some mechanism for very efficiently calculating the height of a particular row. Or don't implement this method and let it do it itself efficiently. So in the will display cell for row at index path, there's a couple of properties like the background color that you can't set when you're loading the cell up. You have to set them here. And you go look at the documentation to find out what they are, but background color is an especially important one. And the reason for that is the background color of a table view cell is also involved in its selection, right? When it's selected, it is blue, and when it's not selected, it's white. So if you want to set the background color to green, you have to do it right before the cell is displayed. Let all that mechanism happen and then override it. You can control the height of the headers and footers too. Again, be efficient here if you have a lot of sections. Make sure that you're efficiently calculating this. And like I say, you can provide your own views for the header and footer, and this is how you do it. You just implement the delegate method view for header and section, or view for footer and section. You give it a UI view, and then you specify the height with the height for header and section, and off you go. I told you that the editing style is controlled via this delegate, and this is the method for that, editing style for row at index path. This either returns insertion or deletion, or it can return none also. And you can prevent the selection of cells too. Okay, so if someone clicks on a cell, this method is going to be called will select row at index path before it does all the work to show this selection, and you could return nil from here if you don't want this to be selected. In fact, you could even return a different cell and it would select that one instead. It's kind of weird to do that, but you could. This returns the cell, the index path to the cell that's actually going to be selected. Okay. All right, so UI table view controller, let's talk about this beast. This is a convenience class, nothing more. Okay, so you understand that right off the bat, this is just a convenience class. This is not a class that's really providing an enormous amount of mechanism. It's a UI view controller. Remember that everything we've been talking about before is UI table view. UI table view is a view. In fact, it's a scroll view. Okay, and it's got these two delegates, data source and delegate. Those are the objects we've been talking about in cells, UI table view cell. Now we're talking about UI table view controller, which is a UI view controller, which implements the data source and delegate protocols of UI table view for you. So when you create a UI table view controller subclass, you can just start implementing data source and delegate methods, right? Because it's set up to call that, call it on itself. But that's really not doing much. It's just setting those things for you. It also implements load view for you. You can have a zip file with the UI table view controller, but if you don't have a zip file, it'll implement load view for you, and it'll set your view, your view controller's view, it'll set it to be the table view. So the table view will fill the entire space. It's kind of like you do in the last assignment when you have load view and it's the entire thing as a graph view. Same thing here. It's going to implement load view for you, makes the entire view a UI table view. All right? If you create a zib with the same name as your UI table view controller subclass, that will override load view. It will not use load view in that case. If you make your own zib, you want to really make sure that the property table view in UI table view controller gets wired up to be the UI table view. Okay? Because the UI table view controller depends on this property, its property in itself called table view, to point to its table view. Now, if you do load view, which most people do, it obviously sets that for you. But if you do your own zib, you got to make sure that's wired up, that outlet. Okay, so what does this thing do for you? It's a convenience thing. What are the convenience things? Okay, when you click on a cell and it pushes something on, you got to make sure that the cell you clicked on gets de-highlighted as it goes off screen. And then when it comes back on screen, you actually want it to be highlighted for a moment and then de-highlight. It's kind of, you'll go play with your phones, you'll see what you want. So it deals with that kind of subtle highlighting and de-highlighting the cells as you push. Also, it reloads the data in the table view. Okay, I missed telling you really about a method that's somewhat important in the table view. I don't really put it in the slides because I don't want you to call it because of efficiency concerns too much. But there is a method, reload data, that you can send to table view. Reloads everything in the whole data. Calls your how many sections, how many rows, calls it all again, reloads every visible cell, etc. So UI table view controller calls that reload right before your view appears so that you don't do any work until you're just about to go on screen. And we talked about why view will appear is a good place to do things like that, so it does that for you. It handles this edit button thing, so if you put this magic edit button that UI view controller will give you into your UI navigation controller bar, then UI table view controller will put you in editing mode and do all the things. Basically, it'll be the target action for that button and do all the right things. It flashes the scroll indicators when the table view comes on screen, if there's any scrolling to be done, which is nice. We talked about how you're supposed to do that. It does that. And here's a really interesting thing, probably the most important thing it does in terms of the most difficult thing if you had to implement it yourself, is if you have a table view cell that has a UI text field in it, which is an editable, like an editable version of UI label, you click on it, a keyboard's going to come up on your iPhone, right? You know, it's going to zoom up from the bottom. Well, you don't want that to cause your thing to scroll off screen, your text field that you're typing in, right? You want that text field to stay on the part of the screen that's still left to when the keyboard zooms up. And so UI table view controller makes sure that it stays on screen, okay? All right, so we have a big demo here. I'm going to do a UI table view. Now, I talked about in the slides a UI table view that shows an NS array of strings. So here I'm going to do a UI table view which shows an NS dictionary of NS arrays of strings. All right? And the keys in the dictionary are going to be sections in my table, and the arrays are going to be the rows in that section. Does that make sense? So this is kind of just one level more complexity than just doing an NS array. It's also, this application I'm going to build pushes an MVC, another MVC, so I'm going to build two MVCs in this demo. It's going to push one that uses a UI web view. This app, I'm calling it Vocabulous, and it's essentially like an app you would use if you're studying for a test, SAT or GRE or one of these kind of things. It provides a list of SAT words or difficult words, and you can click on them and it'll give you the definition of it. Okay, that's what this app does. So I'm going to have two MVCs. One MVC is going to be my word list controller, and its model is going to be a dictionary whose keys are A, B, C, D, E, F, G, H, L through Z, and whose values are a list of words that start with that letter. Okay, that's going to be my model for that MVC. And then I have a second MVC whose model is a word, an NS string, which is a word, and it's going to display the definition of that word in a web view. Make sense? So that's what I'm going to build. All right, so that I can get out of the slides here, quick overview on the homework for this week. No more calculator. We're done with calculator. Okay. This one is called Places, and it's going to be a three-part assignment. This is going to be part one. What Places does is it lets you browse popular photo spots, places where people have taken photos from around the world on Flickr. And so you can browse through what those popular spots are and click on them and see photos from that spot, and then click on, see a list of photos from that spot and click on a photo and it'll show you a photo. So in this first assignment, what you're going to be doing tab bar controller, because you're going to have two tabs, right? A tab that lets you browse the popular spots, and another tab which is recent photos you've looked at. Okay, it's just going to keep a list of all the recent photos that you've shown. You're going to do UI table view controller, because both of those things are going to be tables. You're going to have UI image view and UI scroll view, because one of your view controllers you're going to have to build is one that you push that shows you a photo from Flickr. Okay, and it's going to be want to be an image view inside of a scroll view. Next week, and so this thing that you're going to build is going to be disturbing to you because it's going to be really slow. Every time you click on it, it's like, wait, okay, because you're waiting for Flickr to give you the photo data. But I want it to be that way, because next week what we're going to do is learn how to use threads to do things like network activity, not in the main thread. So our main thread is never blocked. Okay, and we'll have really fast, quick UI that's very responsive, and yet we can still do heavyweight operations like loading things from the network in the background. We're also going to talk next week about persistence, which is basically I want to store something efficiently in a SQL database, it turns out. but I still want to use object-oriented programming. So how do I do that? And iOS has an awesome mechanism for doing object-oriented databases on top of SQL. And so we're going to learn how to do that. And then your assignment next week, obviously, is going to be to integrate persistence and multi-threading into your Places app. Okay? So that's it. Any questions about the table view before I do this big old demo? All right, here we go. Wish me luck. This is a big one. A lot going on here. Okay, so let me use a mouse. Clicking. Let's quit this. All right, so I'm going to build a new app from scratch here. I'm going to call it Vocabulist. I'm going to make it be a window-based app. In other words, I'm going to build all my UI in application to finish launching myself, and I'm going to build my 2 MVCs myself. Like iPhone app, no, choose, and we'll call this Vocabulous. Here it is. Let's adjust. We always do. Hide others. Give ourselves maximum space. Okay, so again, we didn't do view-based app, so all we have is our app delegate. And we don't have any, we only have our main window.zib. We don't have any other things. So I'm going to start by building my MVC that is the word list. Okay? So it's a model view controller. The controller is going to have, so I'm just going to do it as a, I'll describe it as I do it. So let's go new file and create our controller. So I'm creating a UI view controller subclass, but this is a table view one. So I'm going to click this button down here, UI table view controller subclass. Okay, so don't forget to do that when you're creating view controllers, MVCs, where the controller is this UI table view controller. Remember, UI table view controller is just a convenience class, but it is quite convenient, so you want to do it. Now, I'm not going to click with zib for user interface because the only view of my model view controller is just one big table view. So I don't need a zib. I'm not going to put any other buttons in there or whatever. It's just a big UI table view, and UI table view controller will automatically implement load view for me and create one, so I'm good. So I'm going to call this thing word list table view controller. Okay, that's what it is, table view controller. And here's a word list. Let's go ahead and move these up to classes. I really don't know why it doesn't do that all the time. So let's start in our header file for our new MVC, and I'm going to put the model and the view in there. So the model, as I told you, is actually it's going to be a mutable dictionary because I hope to have time to show you how to make this editable. And I'm just going to call it words. So that's going to be my dictionary of words. And it's a dictionary, again, because the keys are the letter of the alphabet they start with. Okay, and I'm going to show you where we're going to get that model in a second. And then my view, actually I'm going to have one other little helper thing, which I'm going to type in here to save time, sections. I'm going to create an array, which is the strings that are the headers for all the sections. So it's basically just going to be A, B, C, D, E, F, G. Okay, that's all this array is. But just it makes the code a little simpler and more efficient for me to kind of capture the sections at the beginning and have that array lying around to do that. And so let's go over here, and I'm going to create a couple of private properties. Oops. One is for my words, NS mutable dictionary words, and one is for my sections, this array star sections. And then let's go ahead and synthesize these two guys. Synthesize the words and the sections. And I'm going to implement the words getter so that when the words getter is called, it lazily instantiates this words thing. Okay, now you're probably saying now, well, where's he going to get that list of words? Okay, and of course I've prepared for this lecture with a little bit of words on the internet. So I have on cs193p.stanford.edu, I've put this thing vocabwords.txt. Okay, it's just a text file. And you can see that it looks kind of like a dictionary, right? You see it has A equals and then parentheses and then an array of words. B equals parentheses and away words. And you might ask, what file format is this? This is old style property list format. Okay, this is the style old property lists used to be. Now property lists are in XML format, but I put it in old style because it's really easy for you to see what the data is. If this was a bunch of XML, you'd be like, trying to parse it out, what's that? You know, whereas this is kind of very human readable old format. But you wouldn't use this format in a real program, but I've used it here just so you can see it. But when you load this if you create a new dictionary using this file, it will create an NS dictionary, and it'll get the keys and the values and make all the strings. So it's really quite nice for a demo anyway. If I was doing the real world, I'd use the XML format, be a little less human readable, but it would be the same thing. So that's our data, and you can see it goes all the way down to Y and Z here. Okay, so let's implement the getter for words to lazily instantiate that thing. So I'm just going to say NS mutable dictionary words, and I'm going to say if, I'm going to scroll down here, if words is not created, then words, well actually I'm going to create my URL first here. Let's go NS URL, my words URL equals NS URL with string, and it is, if you'll recall, http cs193p.stanford.edu/vocab words.txt. Okay, so there I've created a URL. Remember I told you there's this thing NS URL, which is a lot like an NS string, except for it's checked it to make sure that it's a valid format, and that's a valid format URL for HTTP. So that's perfectly fine. And now I'm just going to say words equals NS mutable dictionary with contents of URL, that URL. Okay, it's as simple as that. That's how easy it is to go out on the internet, get a URL, pull it in, have it parse it to turn it into a big dictionary. Voila, we have a dictionary, a mutable one, because I sent this to NS mutable dictionary instead of NS dictionary. So we're rocking here, and that's it. So we'll return words, and that's my getter for my words property. Okay. I'm also going to implement a getter for my section, so you can see what that's about. So all the sections thing is going to do is I'm just going to grab the keys out of my words and sort them, because I want my sections to be in alphabetical order. They are in that file, but they might not be. But I just want to show you how to do sorting, because you're going to have to do that for your homework. So here again, lazy instantiation. If sections is not created, then sections equals, I'm going to get my words. I'm going to get all the keys out of there. And I'm going to do the sorted array, using selector. And the selector I'm going to use is compare. There's also case insensitive compare would be another option that we could do. And I am going to retain that because the sorted array using selector returns an auto-released array, and I'm going to hold on to this section. It's an instance variable, so I need to retain it. Okay, I also need to release it, which we're going to do in a second here. So that's it for sections. Now let's go right down here to dealloc, way down at the bottom here, and release both our words and our sections. Okay, because they're instance variables and we retain. And words, you can see that actually we need to do something here too, which is this needs to be retained as well, right? Because we remember that the method dictionary with contents of URL doesn't start with alloc, new, or copy, so we don't own the thing it gets back, and we're going to keep it, so we want to retain it. But since we're retaining them both, we got to release them both. Okay, sure I'm not forgetting anything here. I think that's it. All right, so now I have my dictionary, and I have an array of all my sections. So now let's implement those data source methods that give the number of sections and the number of rows and load up the cell. Okay? So actually, if we scroll down here, when we click that button that said we wanted a UI table view controller subclass, it's created a lot of things. Like here is the designated initializer. Here's view did load. Here's view will appear, disappear, all these things. Here should auto rotate. And here is the methods in the table view data source. Okay? So you can see right off the bat is the first one, the number of sections. Now, the number of sections in our case is really easy. That's just self.sections.count. Okay? That's the number of sections in our sections array. Very, very simple. And then the number of rows in a section, slightly more difficult. We got to get the words in the section first, so I got to go ns array, oops, star words in section. Sorry about this keyboard. Equals, and I'm just going to go into my words dictionary, and I'm going to get the object for key, this section's name. Okay, everyone understand what I did there to get the sections? I've got this dictionary of arrays. Okay, the keys are the names of my sections. So here I'm being asked how many rows are in section number 3, let's say. So I go look in my sections array, get the name of that section, which would be like C, the letter C or D. And then I'm just going to look up in my words the object for key D, which is going to be an array, okay, array of words. And so now I'm just going to return words in section count, okay, which is the number of rows in that section. That make sense? Okay. So now we've let the data source, we've implemented the data source. This is how many sections, which is going to be 26 or however many letters are in there, and how many rows in each section varies from word to word, like Y and Z only have one, but A has a whole bunch. And now we need to load up the cell with the actual word for a given section and row. And you can see here that it's already implemented that whole DQ business for it here. You see, DQ, blah, blah, blah. I might want to change the cell identifier to be, you know, word list table view or something like that, or table view cell, something like that. Something that's unique to my, so I'm not sharing a queue with some other table view somewhere in my app. That wouldn't be what you wanted if, unless you had really generic cells that were always resetting all the attributes of it. So configuring the cell, super easy here. I'm actually going to create a little method to get the word in a certain row in a section. So I'm going to say cell.textLabel.text equals self word at index path, which is a method I'm going to create. Index path, okay, this index path is passed into me here. Okay, and remember index path is just a section and a row. That's all it is, an object that has a section and a row. Also, when I click on this, it's going to push something, right? It's going to push that web view. So I have to say cell.accessoryType equals UI table view cell accessory disclosure indicator. Okay, I want the little greater than sign because I want the user to know that when he clicks on this cell, it's going to push something. It's going to give me more information. So let's implement this method, word at index path. Okay, ns string, whoops, word at, paste, word at index path. It takes an index path. Ns index path. And that's just going to be the section and row. And we're going to do the same thing we did up here, actually. Let's get the words in a certain section, although we need to say indexPath.section here. And then we have the words in a section, so let's just return, not retrim, return words in section, object at index, indexPath.row. So you see how I've used the section and the row here? Get the section to go look in the sections, find the thing, get that array, and then once I have that array, then I'm using indexPath.row to pick the right word. Make sense? Okay. Now we're almost ready to put this table view on screen. We've got it so it's loading its data. It's got its model all set up. The last thing we need to do is go into application did finish launching with options and put this thing on screen. So let's go ahead and do that. All right, here's our app delegate. Here's application did finish launching with options. This is really easy. So I'm just going to say word list table view controller, word list table view controller equals word list table controller alloc init. Then I'm gonna create a navigation controller because I know I'm gonna be pushing. So let's go ahead and put it in a navigation controller now. So UI navigation controller, nav equals UI navigation controller alloc init. Then let's just push this thing, WLTVC, animated no, and then WLTVC release. Okay, and that's it. So that should be all that is required. Let's now cross our finger. We got to import. Downside import. Wordless controller. Okay, so let's run this. Cross our fingers. Oh, didn't work. Okay, so. Oh, sorry, yeah. He's like, oh, that's great. We did a wonderful job there, except for we never added subview. Okay, so there's our nav view. I bet that's going to work a lot better. Okay, so here's our navigation controller. Lots and lots of words, okay? Now, we don't have any section headings. That's no good. So we want to try and fix that if we have time. And of course, if I click on one, it doesn't do anything. So that's no good either. So we need to have our second model view controller and push it. Okay, but at least we're doing pretty well here. All right. So let's go ahead and do our other MVC. I'm going to call this thing, it's a view controller subclass. It is not a table view. It's just going to be a web view. I'm not going to use a zib for this one either. I'm just going to do load view. Get you see more of that. And I'm going to call this definition view controller. Okay, because it's going to show the definition of a word. All right, so let's do this thing's model and view. So its view is a web view, and its model is just a word. And I'm going to make a public property to let people set that word. Notice it's a string, so I'm making it be copy instead of retain. It's common. We've talked about that many times. So let's go ahead and synthesize word here. Synthesize word. I'm going to do load view first, just because it's very easy. Void load view. We're just going to create a web view, which is UI web view alloc init with frame. And I'm going to use that thing I was telling you about before, UI screen, main screen, application frames. Probably going to put this in the wrong place. Yes, it did. No, this goes here. And here. Okay, so there's a web view, and then self.view equals web view. Okay. Now, this also, I could set up some attributes here, or I could do it in view did load. I'm actually going to set one right here, which we want, which is scales pages to fit. So that's the thing that causes the web view when it shows a page, it scales it to fit in the space available. So I want that. Let us implement the setter here for word. Set word to a new word. And if the word is new, then I'm going to release the old word and set word to be a copy of the new word. And then when someone sets the word, I'm going to load it up in my web view if it's on screen. Okay? I'm also going to set my title, set my UI view controller's title to be my word. And then I'm just going to say if my web view is on screen, you all remember how to do that, then web view, and this is how we do requests, right? We do load requests. And I'm going to create a little method to create my URL request, and we'll implement that. And that's all we're going to do. So when someone sets my word, if I'm on screen, I'm going to display it. I'm also going to have to, in view will appear, when I come on screen, I'm going to have to display it as well. Let's put that little NSURL request method in here. URL request. This is our URL request. What we're going to do is we're just going to ask Google to look this word up for us. Okay, so real simple. So I'm going to create string here, URL string, and it's going to be http://www.google.com/dictionary. And if I have a word, obviously I want it to look up that word. I don't want it to just show dictionary. So I'm going to say if self.word, then URL string equals URL string, string by appending format. And this is what you do. Question mark, language pair equals English, and then %7C to English. So we're translating from English to English. And the query word is %@, which is our word. Okay, so there's a little bit of Google magic for you. And then we're going to return NS URL request, request with URL, NS URL with string. Okay, so there's a lot of complicated typing there. All right, so now we've set our thing up so that it automatically does that. Like I said, in view will appear, which is probably somewhere in here. Let's do it right here. I want to make sure that I also load it up. So in view will appear, I'm just going to do super view will appear. And then I'm going to say web view load request self URL request. Okay, so that way when my view comes on screen, if it wasn't on screen when the word got set, it'll get set now. And that's a common thing you want to do, set things in the setters, but then also to make sure you do it in view will appear so that depending on when the word gets set, whether it's on screen or not, it'll get updated properly. And then the last thing we need to do is when we click on something in our other model view controller, we need to push one of these guys on screen. So let's go to that code. That's back here in Word table is. And remember I said that's a delegate thing also. Here it is right here. Table view did select row at index path, gets sent to us. And in fact, even the comment here tells you go push a view controller. And that's exactly what we're going to do. So we're going to do definition view controller DVC equals definition view controller alloc init. We're just going to set our word to be our word. And we actually have a method. That's why I created a separate method over there, which is word at index path. And then I'm going to push it on my navigation controller. Push DVC, animated yes, because we're probably on screen at this point, and then DVC, VC, release. Okay? Failure here because of imports as usual. Unsigned import, definition view controller. And there we go. Okay. Everyone got that code? Make sense? So let's see if it works. All right, we have our words. That's good so far. We'll click on one. Oh, it worked. It's kind of hard. We got to zoom in a little so we can see on this tiny screen. But belittling is make someone or something seem unimportant. That sounds right. Let's go down here. Clemency. How about that? Clemency is mercy or lenience. Okay? All right, so everyone cool with that? So I'll be posting this code. Let me, we got 4 minutes left. See, can we do something quick? How about the section headers? Let's see if we can do the section headers in 4 minutes. I think we can do that. So I'm just looking to see if it's already in here. Commented out, table view. Probably, nope, it's not. Okay, so let's put it in here. So the method is NSString. I think it's called section header. Well, let's go look it up to make sure. So we're going to go, I'm going to bring up the documentation. And actually, I'm going to look up UI table view data source, which is where this thing is going to be. And we're going to scroll down, and here's the list of things it can do. And you can see that here is table view title for header in section, which is what I want. So I'm going to go back over here. Table view, that's the sender. Title for header in section. And this is going to be an NS integer section. Now this is really easy for us to implement because we have that array of sections. So I'm just going to say return self.sections object at index section. All right, so let's see how that goes. Oh, look at that. See the A? Now notice how the section header stays on screen as I scroll through the A's, but when I get to the B's, watch what's going to happen here. See the B coming up? The B is going to replace the A. Okay, so that all happens automatically. Okay, and if we have multiple, if we get all the way down to the bottom, you can see we can obviously have multiple headers on screen at the same time. Okay. So what I don't have time to do today, but I will post the code for this tomorrow, is the editing. All we're going to need to do to edit in this thing is implement that commit editing style. And when we do two things in there. One, we delete the word from our array. Now that's a little complicated because we got a mutable dictionary, but it's mutable at the top level. So we could add more sections, but it's not mutable the next level down. So we'll actually have to get the list of words, make a mutable copy, delete the word, put that mutable copy back into our dictionary. Then now our model's up to date. Then we will call the table views method delete this row at index path. Okay, so that way we'll have satisfied both a responsibility to our model and to our view. Okay, so that's it. Thank you very much. Good luck. Your homework is basically doing very, very similar thing to this, so hopefully it won't be too difficult. And I will see you next week.
For more, please visit us at stanford.edu.